All right, so my name is Jameson Morgan, and I'm a graduate student at Wright State University in Dayton, Ohio, and my advisor is Dr. Derek Doran. And today I'm going to be presenting an update on our process for generating synthetic vehicle data sets using SUMO. So the goal, hang on, I gotta minimize all the screens. Okay, the goal is to produce synthetic trajectories that have demand patterns that we see inside representative trajectories. And representative trajectories are those trajectories that we're able to capture from the real world, from like GPS, maybe some form of like a camera system or CDR data. And what we want to do is we want to take patterns that we see in those, and we want to create synthetic trajectories that have those patterns. So the goal behind this is obviously trajectories provide us a lot of information about the environment and the geospatial dynamics of an area. But often for a researcher, while those are valuable, they're not really available to us because of privacy concerns, ethical issues, maybe even the sampling frequency isn't that good. Sometimes, their check-in times are very, very long. Another issue is just researcher access. So, they might be behind inside some company, like a cell phone provider, but they're not going to give that publicly available to you without different type of agreements. So a solution to this is to create synthetic trajectories. But unfortunately, if those trajectories aren't calibrated, they often won't be useful for a study or something like that. And so what we want to do is we want to take information that we see from the trajectories and build synthetics that are better calibrated. So to do this, we present a GeoAware framework. And of course, in the upcoming poster breakout session, I'll go into detail more on this if anyone's interested. But on the left-hand side, the GeoAware component collects a bunch of demand pattern models, and it incorporates those demand models into a scenario. And that scenario is then simulated using the libsumo-R component to produce the synthetics that we seek. And this libsumo-R component relies on SUMO for the fine level routing and position and car following, lane changing, that type of stuff. But then what we do is we enable this to be used to the analyst from the R programming environment. So the main takeaways for this project are that synthetic trajectories are useful, but are often unavailable to us. And so we present a synthetic framework that will generate synthetic trajectories that incorporate demand patterns we see in the real world, but aren't actually those real world trajectories. And we incorporate this into a package for the R programming environment that features a kind of read, eval, and print loop type access to SUMO from R.